Hello viewers, welcome to week 2 of Python to Gen AI course. In this week we will cover different topics which are Python essentials. First we'll go through functions. Next we will see how to handle errors. And next we'll see different file operations, how to read CSV file, JSON file, text file, and how to read, write, how to append. So a lot of file operations we'll go through. And we will also cover one interesting topic and important topic called asynchronous programming, which is very much important while doing the Gen AI applications. So on that note, let's start on the first topic, functions. So what is a function? It is a reusable block of code in simple terms that performs a specific task. So why we use functions? See, if you have any single file, let's say you have 1,000 lines of code, and if you want to reuse any logic, or if you want to maintain code easily, and if you want to maintain any like modules, it is very tough if you're not writing any functions. See, for example, if I'm adding two numbers, if you have any module which will add two numbers, or which will find even number, which will find odd numbers, or which will find out any Fibonacci series like that. So if you have a ready-made functions, you can reuse that in the entire code wherever you want, rather than every time repeating that block every time. It is always a tedious process, and it's a not good way of practicing a software programming. So the best answer for it is you need to write a function. So in simple terms, the function definition is, so it starts with def, it means define a function in Python. So greet is the function name, and this open and closed loop parentheses are telling us this is a function, it's not a variable. And you end the function with a colon. And once you define the function, in the next line you need to put a space here, like parentheses, like 4 spaces should be maintained, and you need to retain the body of the function, or you need to write what that function does. If it is like find even number, find odd number, like that, you need to write what my purpose of that function is. So here greet means, yes, I just want to print hello world, and this is just defining the function, you are not calling the function. So to call the function in Python, you just need to call this with parentheses. Okay. So this is the simple, in simple words, what is function. So this is the syntax, and please ensure you maintain the parentheses and end with colon and start with def here, and maintain the parentheses. In next, we'll see how to pass parameters or arguments to this function. So now let me run this simple function here, greet. So I call the function, it is telling hello world. So now let's do a bit more on what is happening inside a function. So as I mentioned, these are the parameters. 1 second. Yeah. So function definition by syntax will go. So yeah, as we discussed here, this is the function name, greet here the function name, and the here there is no parameters, but obviously you need to pass some parameters here, and you can return the value from the function. So let's say if you're adding two numbers and you're passing that parameters, what is that, a and b, and finally that function should sum those two numbers and it should return a value. So whenever you are returning a value from the function, this return statement is must. If you don't mention this, and if you just type value, it's just a variable, it's a data type, nothing else it is doing. So so there will be functions, there will be two cases. One is non-returning function and one is the returning function. Non-returning means the function does some operation, and it doesn't return anything, whereas the returning function means it does some operations and it will return some values. Actually here you can execute some code and you can return that value or whatever parameters you are passing. So here the def declares a function and the function name and parameters, colon starts the function body, and indentation matters, and return sends a value back to the caller. Yep. So yeah, this is optional. Whenever you want to return, only you return. If it is not required, there is no point of returning. So now let's start with few very simple examples. So I'm just first. So here, what is a function? Add numbers. I'm passing two. The function has two parameters, a comma b. Okay. And what I'm doing inside the function, I'm adding those two numbers. Result is equal to a and b, and I'm returning the result. Okay. So let's see how now. This is my function purpose. So how to call this function? Add numbers, and you pass here 5 comma 3. This 5 comma 3 are called arguments, and a comma p are called parameters of the function. Okay, so will discuss parameters means variables in the function definition. So this is the function definition, and a comma b are called parameters of that function. How many parameters my function is having? 2, 3, 4, 5. But what are the arguments you are passing at the time at which you are calling the function? Whatever actual values you are passing, those are called the arguments. Okay. So now let's run this function. So you can see here 5 comma 3. So 5 plus 3 is 8. It returned 8. So my sum result is 8. You everybody know this is like a string formatting in Python. So we already covered that in week 1. So I'm not repeating that again. And next thing is parameters versus arguments. Yes, we already seen this. What is the difference between parameter and argument? So this multiplies a comma b or parameters, and this 4 comma 5 are called arguments. So the time at which we are calling the function, those are called arguments, and whatever things that are defined in the function, those are called parameters. Okay. So now the return values. So yeah, functions uses return keyword when they use if you want to return any data type. So if you're not using, the function returns none. So which is equal to you're not returning anything. So once return is executed, the function stops immediately. Okay, so please remember the return should be the last line of your function. After return, if you write any code here, it will not execute. So for example, if you write here a is equal to something like 10, so this will not executed by the Python interpreter. So as soon as the return is done, the function exits from here. Okay. So now here we have a simple function get square. So we are passing a variable x here, and we are returning. The parameter of the function is x, and I am returning the value of x star x. So it's like this like get square function. Okay. So the result is get square 7. 7 times 7 is 49, and if you print it, you will see 49. And I have a one more function. So this function has no return. Okay, I mean the function name is no return, and which symbolically tells I'm not returning any value from this function. I'm just printing it. So now let's try see what happens if you call both the functions with return type and without return type, and try to see if you're printing what happens here. Yep, here it is straightforward. Square of 7 is 49 because you are getting the return value back from the function. But here you are not returning anything from the function, you just calling the print function. So when you call no return, it should return none. So return value is none. Okay. So if you're not returning, by default, the value is none. So in Python, we have a feasibility where you can return multiple values, not just the one value. So for example, here is my function, get min and max. And the parameters is numbers. Okay. So here the numbers means you can pass any data type to that particular parameter of the function. Okay, you don't, it's not in Python, it is like auto detectable. It's not like I should only pass int here, I should only pass float, I should only pass complex number, strings like that. So at the time of declaring the variables or data types, Python automatically dynamically tape it. You don't need to worry like, okay, I need to explicitly define any data type. Okay. So here I have a function get min max numbers, and then what I'm doing is I'm returning both min from that numbers and max from that numbers. Okay. So here the numbers is a list. So from that list I should return min and I should return max. So now let's start with calling that function get min and max, and this is the array list numbers. So min is 1 and the max is 9. So you can return both. So just ensure whatever the order you are returning, try to maintain the same order in the return type. So for example, if you swap max and min, you might be in a confusion. Okay, what 1 is maximum or 9 is minimum, like that. So just ensure whatever order it is returning, in the same order you declare this return variables here. Okay. So here I'm not doing anything. Actually, the return types I'm just storing into a local data variable, and arguments can be list anything or any string, int, whatever you can. So Python is dynamically binded. So now let's see what happens here. So I'm calling this get min max numbers. So I'm passing the list here. So it is returning min comma max. So I'm printing that min comma max. So why it is showing the data type as tuple? Because this is the by default it is a tuple. So when you are returning multiple values from your function, you need to follow in this syntax way. By default, this is nothing but you are returning a tuple. So that's why I'm unbounding the tuple in the same order I bound it. So min, max, minimum, max. I'm printing min and max, and I'm storing that in a result. So it is nothing but a tuple here. So you can unbound, you can explicitly unbound min and max, or you can just put the entire tuple in a number and then you can just the type of that number. Just to understand, help you what is happening here. Okay. So you can unbound, you can just in the same order you can return, or if you're not sure what is the order, you can just simply declare everything is in a result, and the but result type is tuple, and you need to ensure okay what are there inside that tuple. So this is min and this is max. And one more interesting topic is local variable and global variables. See here you have, so local means a variable defined inside a function, it has a local scope, and the variable which is defined outside the function, it has a global scope. See, let's say I have two variables here, count. So one is global variable and one is a local variable. Count equal to count plus one return count. Okay. So what is happening here when you call increment? Whether that will increment the global variable or whether it will increment the local variable count. Okay, so here you will get an error because you are trying to increment a same data type which is declared both global and local. So you see this creates a local variable not modifying the global. Unbound local error. This is the error you are getting. Unbound local error, and it is telling to use global variable, use the global keyword. So whenever any variable, if you declare outside the function, the better practice or the best way is to use a global variable, global keyword, and then use it. So for example, here I am telling global count. It means explicitly telling count is a global variable. You start using it. Okay, now count equal to count plus one, return count. Now if you try to execute it, it should return the value, the one. Okay. So this is the difference between a local variable and a global variable. So you can declare, see for example, you can tell a is equal to 10, or you can tell a plus plus or 10 plus 1 11. So all the operations you can do, but this a is a local variable, not a global variable. Okay, so for example, if you do a is equal to a plus 1, return a, and then you call this increment, I just simply execute it. Yep. So here, yeah, here I'm not printing it. Let's print it. But this time you see there is no error. It's because a is not a global variable, it is a local variable, and I'm just printing it or returning it. Yeah, you see the value is 11 here and there is no error because 10 plus 1 11, and you can store that variable like this also. Answer is equal to, and then you can print it whatever way is best suitable for you. Okay, so this is the difference between a local variable and a global variable. Just one last time, see here a local means it is inside the function, global means outside the function. But if you're trying to use any global variable inside the function, so the best practice is you just mention the global keyword like this, global count. Okay, and then start using it. So let me execute this cell, and the next is positional parameters. Positional parameters means, see here we have a function definition, and what are the parameters of this function? A and B. So when you're calling this function, the arguments you're passing is 10 comma 3. So in the same order, these arguments will be assigned to these variables. So now a is equal to 10, b is equal to 3, 10 minus 3 is 7. So now you assign 3 comma 10. So same values will automatically in the order it will be assigned to the parameters of the function. A is 10, a is 3, b is 10. So the result is minus 7. So these are called positional parameters. It means whatever order you declare or whatever arguments are passed, same order it goes to the function also. So now there is a different flexibility in Python where you can use named arguments. See, let's say this is my function, and this function is returning a JSON object, or it is returning a string like this: name, email, age, and the parameters of this function are name, email, and age. While calling the function, oh, this is the positional way of calling. So directly the name is Alice, email is Alice at the rate example, and the age is 25. It's straightforward. So there is a one more way. If you're not sure about the order, you can type like this: email with the parameter named arguments, email is equal to this, and name is equal to this, and age is equal to 30. So these parameters you can reuse while calling the function explicitly. So, but this should match at least these parameters. You cannot simply tell, okay, so this email. So, but this is not part of the parameters of the function create user. So you need to ensure the named arguments means whatever argument you are passing, ensure to which parameter this should be binded to. So here email is this, name is this, age is 30. So here you are not following the order, but you are ensuring your call that the meaning is still the function calls take it in the properly. Okay. So you can also use mix of both. So I can just call this parameter as it is. I'm passing this argument. So it goes in the order now. So the name is Carol. So now age is 28. The email is, so it accordingly it will pass. Now age is 28 and email. So no need of order from here. So you can follow combination of order or without order or order plus order. So that technical terms are positional arguments or named arguments. Okay. So let's run this. You can see here the first case it is name, email, age, name, email, age, all are coming correctly regardless of the order you passed. Okay. So the next concept is function best practices. Yes, there are multiple ways you can write a function, but the best practice is to always check some error conditions before returning. Okay. So this calculate function, price, discount, and discount amount it is calculating and returning. Okay, good, clear, focused function. So there, yeah. So in this case, it's already a good function. But in few cases, so divide like this a comma b. If b double equal to 0, you should tell, okay, I'm not attending any exception or any dummy values. Actually, whatever parameters you are passing that has some invalid values. So it's always recommended ways do some type checks here, provided if it is required. If you're doing multiplication or subtraction, there is no need to do any type checks here. You can just type checks means like return types value, whether it is 0 not 0 or whether it is deep. You can write your own things here. Okay. So this is a good. So just ensure do provide. We'll discuss more about this thing in the error handling, how to handle this type of errors. But for now, just remember, it is a good practice inside of functions if you can handle some uh, errors which are best known to you. Like here, if b is equal to 0 means a by 0 is infinite. So it's not the computation wise it is wrong. So better you just return that error here. Okay. So when not to use functions? So now there is a function and you keep using it. Okay. But it's not like, it's like AI. AI is there. And for every problem you are using AI. So it's not like that. If at all that problem requires AI, then only you should use AI. Similarly, yes, functions are there, but it's not all the time you should use functions. Whenever it is required, you can simply go ahead and use it. So here I am telling one raw, not recommended way. So this is one line, global data append something. So for this, you don't need a function. You can directly call this in the main function and then just do it. But if you are doing any kind of at least some operations, some copying operations, if you are doing some computations inside it, yes, you definitely need a function. Okay. So what are the key takeaways? Key takeaways. So functions, how to use, I mean the parameters and arguments, return values, scope, local variable, global variable, named parameters, default parameters, functions, when they are useful. And of course, in AI and data science functions, all the algorithms and model predictions, you have a functions. You just need to call those algorithms from the Python, respective Python libraries. Yep. So that's how the functions are important. Hi everyone, welcome to the lesson on Python functions. In this video, we will talk about default arguments and variable arguments. In variable arguments, we have two types: positional arguments and keyword arguments. So let's look into that. So by default, a function can take any number of parameters. A function can be defined with any number of parameters. So it's not like that you only have two parameters here. You can have n number of parameters like name, greeting, email, login, IP address. Like that, you can define any number of parameters, and you need to call that particular function with the help of arguments. So here I am calling my function greet. Now the output is hello Alice. So what happens if user doesn't provide any input while calling greet? Okay, any input means, let's say, if I forgot to use call put hello here, and he just by unknowingly he called just the function with Alice. So how do you handle that cases? So the good way to define a function is you can just define a function with some default values. So here name, it is a one parameter, it doesn't have any default value, but greeting, it has a default value called hello. So now if user just passes Alice argument, so he will get hello Alice, because hello is a default greeting. Now you can use this. Okay, if now here user is passing hi, so we are getting hi Bob. Here user is passing hey, so you are getting hey Carol. Okay, so it is a good practice to define a function with parameters, and that parameters should have default arguments such that if user doesn't provide any argument for that specific value, that particular parameter, the default argument will be automatically assigned. Okay, so that's the importance of the default arguments. So now let's see what are positional arguments. See, let's say you are, as we discussed in the previous case, let's say you have like 10 parameters in this function, like 10 to, it is accepting more than 10 arguments, more than 10 parameters. So in that case, it is very tough to define a function with such number of parameters. So what we can do is, there is a wildcard. This is called a star args. It means it can take any number of arguments. So in general, if your function has more than 5 6 parameters, we don't define all those parameters here. You just simply use this one keyword or just one particular variable called star args. It means it can take any data type as argument, and regardless of the length of the arguments. Okay, so here we have a function called sum all, and here we are calling sum all 1 comma 2 comma 3. So it means we are calling this function and we are passing the parameter arguments 1 comma 2 comma 3, and the star args will treat this entire thing as a list. This everything will be taken as a list here. So that's why I'm iterating in the list. For num in args, total plus is equal to num, return total. So you pass 1 2 3, so that will pass as a list. The entire arguments are passed as a list to this function star args, and if you iterate to this list args, you can compute the total here. So here 1 comma 2 comma 3, sum is 6, and 10 20 30 40 it is 100, and sum all is nothing is there, so you'll get 0. Yes. So this is what happening here. So sum all 10 20 30. So this entire parameters are passed as a list to this function, since this function is accepting variable position arguments. So that is the importance of this star args. You don't need to define all the parameters. It will be tough. Okay, how many parameters are there inside the function? The easiest way to maintain is this. What if you have only 2 to 3 parameters, your function, you can just straight away define like above, name, greeting, like that. Okay. So the next important arguments for the function is keyword arguments here. So here we represent the star keyword argument, star kw args. Kw means keyword arguments. So here, yes. So this kw arguments by default, it accepts your parameters as a dictionary. Okay. So here my build profile. So here I'm passing key argument, key argument, key argument. So my key is name, value is Aisha, key is role, value is data analyst, key is level, and value is intermediate. So we can directly pass your parameters or your arguments to the function as a dictionary using keyword arguments. So now what happens here? Yep. So this is a dictionary key value. So you can also confirm this print type of profile. So you can see now the object will be Yes, dictionary object here. So here in positional arguments, you can pass everything as a list, the entire parameters as a list. Here, all the parameters, all the arguments can be passed to the function as a keyword arguments or as a dictionary. So you don't need to worry, okay, my name is this, Alice. So you don't need to define all the parameters inside the function. So we'll be using this when there are no more parameters are required for a function definition. Okay. So you can also use default arguments in general. So default arguments, positional arguments, keyword arguments. Yes, you can also combine all these arguments. So here is one example. So event, so I am having a function called log event. The parameters are event type. This is just a normal parameter and level is equal to info. This is a default parameter. If user doesn't provide level, by default it takes info. And here I'm telling it take any number of arguments and take any positional arguments or any keyword arguments also too. So let's see one example. See here log event and let's first run this. See login event type and level is info. Since you are not passing any positional arguments or keyword arguments, it is showing empty here. Okay. So the next is upload event type level is warning. And here you are passing this as a list. All the rest of the parameters will be taken as a list. File 1 and file 2. And these two parameters are taken as keyword argument parameters by default. Okay. So that's why you are getting here type. I mean, yeah. So the type is upload, level is warning, and event type is upload and level is warning. And what are the arguments you passed here? File 1 and file 2. Positional arguments. What are the keyword arguments you passed from here? User address and IP. So you can depend upon the requirement. You can just use default. You can use positional. You can use keyword arguments or combination of all or just the name arguments, whatever. So there are different flavors or how do you define a function. Okay. So now let's look into a practical example how these positional arguments or keyword arguments are helpful. See, I have here a function called calculate. Here star numbers means this takes this is a positional argument, not a keyword argument. It means it accepts parameters as a list or arguments as a list. So and the default operator is plus. If you want, you can override this or you can define our own operator too while calling the function. So here if the list is empty, if not numbers, so this is how you check whether the list is empty. If the list is empty, there is no need to perform any operations. You return 0. And next is, yeah, if the operator by default, the operator you need to perform to the list is plus. So if operator double is equal to plus, of course it is plus, but just here we are double checking, that's all. So for numbers, I am iterating through the list and I am returning the sum. While calling this function, if the user provides what operation do I need to perform, for example, if we pass multiply operation, so you can just return this. So like that you can, if user provides any other for simplicity, I'm just supporting only two operations, but he can provide division, modulus, all those things. You can just write, you can expand this function here. So there is no need to, for simplicity, I'm just returning unsupported operator. I'm only supporting only two operations here at this point. See, the advantage here is you can pass any numbers here, 1, 2, you can pass 100, 200, it's a list. That list can, length can be anything. And you can also write very generic function here. Okay, by default, I am performing plus, but you can also extend this functionality while you're practicing. So let's run this once. So you can see here calculate 1, 2, 3. This is passed, these arguments are passed as a list to the function. So since operator did not provide any operator, by default plus operator will come. So 1 plus 2 comma 3, it is 6. And second time I am calling this function 2 comma 3 comma 4 and I am telling my default operator is star. So this entire thing goes as a list and operator is star. So 2 into 3, 6, 6 into 4 is 24. So that's what you are computing here. Okay, here I am not passing anything. 0 into 0 is 0, 0 plus 0, 0. By default it is plus means, yeah, we are telling if result is 0, just don't do anything, return 0. Okay, I mean this will call, if not numbers, return 0. Because there are no numbers here, I'm putting an empty list, yes, you are returning 0. It will not even execute these functions, these if conditions. So let's compute. Yeah, already computed 624 and 0 is the output. Okay. So this is the importance of how do you define a function so sophisticated, more generic, so it accepts any inputs, all those things. Okay. So that's all about the functions in specific about positional arguments and keyword arguments. And yeah, so the key takeaways are yes, default arguments makes function call flexible and easier to call. Star args or positional arguments calls position arguments into a tuple or a list, and keyword arguments calls extra keyword into dictionary. So the correct order, parameter order is yeah, first it will take regular default args. So this is the hierarchy. So in AI and model, you will use a lot of KW args for hyperparameters. So what are hyperparameters? All these things we'll do late. We'll discuss in the Gen AI because there will be a lot of inference parameters for the model. There will be like around 100 to 50. So you cannot call function every time passing all the parameters. You will simply use this star keyword arguments. Okay. So that's all about this. Hi everyone, welcome to the lesson on Python functions, and today we'll discuss about Lambda functions, also called as anonymous functions. So let's start the discussion on Lambda functions. So first we will look at one simple example and then go its definition and syntax. So here we have one regular function, define a function called square, which takes one parameter x and it returns x star x. This is one regular function, and if you just call this function square of 5, you will be able to call this function and returns 25 here. Simple, straightforward. But you can represent this function in a different way in one line using lambda, also called as anonymous function. So here this is the syntax lambda. Lambda is a Python keyword. Okay, it's not any variable or nothing like that. It is just a keyword by defined in Python. So lambda x is like the parameter, and colon x star x means the expression you are writing. Okay, or indirectly you can tell the what function does indirectly, but in terms of lambda terminology we call this as expression. Okay, so now you are assigning this entire function into a function variable. Okay, so here square underscore lambda is a variable, but it holds the function variable. It is a function variable. It means it's also called reference to the function. Square underscore lambda is a reference to the function. It is not any variable like that. Okay. So now you can call this lambda function using its reference square underscore lambda. So print square underscore lambda of 5 will call this anonymous lambda function 5 star 5 into 5 25. Okay. So this is the regular function and this is how you call it. And this is the lambda function, also called as anonymous function. So we are just providing here the reference of this entire lambda function to this variable. So this is not the definition of the function. This is just a variable which holds the function's address, or you can call it as function reference. So you need to call this lambda function using this function reference, or the variable which holds the function as a reference square underscore lambda of 5, which gives, now this will call this function 5 into 5 25 and automatically returns the return type. Okay, you don't need to explicitly mention the return. So these two words, this entire function is wrapped into one line here, and this is just, we are just assigning, it's nothing much actually here. Okay, so that's how you, so the result is same. So and the syntax, yes, so lambda keyword passed by, followed by arguments, followed by colon, and then space expression. So lambda means it starts the definition, arguments are input parameters, comma separated anything, it can take any data type, and column separates parameters from the expression, and expression is evaluated returned automatically, no return keyword needed. Okay, so this is about from the syntax perspective. Now let's see more use cases of lambda. See here, yeah, I have one more function called anonymous function, doesn't have any name. So lambda, a function that takes x as an argument and it had an expression which does x star 2. Here I am just passing the entire function reference to a variable called double. So here I am calling this function reference double of 10. Okay, this indirectly calls this function. Okay, this lambda function. So same here, lambda. Now I have here two arguments, a comma b, which is the expression is a plus b. So 3 comma 7, I'm calling this function reference 3 comma 7. So which calls this lambda function. 3 plus 7 is 10 and it automatically returns value 10. Okay. And here lambda with 3 arguments, same. So here I'm defining a function. I'm just defining a function, a variable reference to this function. And I'm calling that function reference or variable reference using volume. And I'm passing the parameters volume 2 comma 3 comma 4 and it prints. Okay. So if you can, I can just show you one more thing. See if you can type here print type of double. Now let's see what is the type. See, this is of a class function. It's a function variable. It's a function reference. This is not a data type variable. Okay. So just be careful about that particular variable where we are assigning the whole function to it. Okay. So this is about the basic use case of Lambda. And now next we'll go to Lambda for differences between Lambda function and regular function. Both achieve the same result, but it has different use cases. Yes, here it is the whole. Yeah, see when the logic is big, if it takes more than 1 to 2 expressions, here we have one expression discount percent less than 0 or greater than 1000 return price, else you need to do this a lot of computation is required. So in these cases go with the regular function, better for complex logic, and you just call this function will call, all good. When do you choose lambda function? When the expression is simple. For example, here I have price and I want to compute and I want to multiply each the value inside it with 1.1 with the variable price. So 100 into 1.1. So like this, simple computations you can use lambda. We will go very interesting examples down. So but just example from the usage perspective. So just remember use lambda when you have one line expressions or very simple expressions where the computations are very less. In that case, the whole thing can be whole function definition calling everything can be just replaced in one line like this. Okay. So now let's execute the cell. You will get this. Okay. And the next, let's see some more use cases of lambda. So here you will be exactly, I mean, you'll come to know how important the lambda's functions are. See, look at very interesting use case here. So this is my list. Celsius is equal to 0, 10, 20, 30, 40. So my main aim is to convert all the Celsius value into the Fahrenheit. Okay. So what is the regular logic you will use? So you will create an empty list called Fahrenheit, and then you will iterate each value inside the Celsius, and then you keep append convert that uh, Celsius with this formula C star 9 by 5 plus 32. This converts Celsius into Fahrenheit, and finally you append that list. So this is how the typical you want read, but the more simple, since the expression is very simple here and you don't want to do all these computations, you can just replace this entire three lines into one line, like Fahrenheit is equal to list of map of lambda c star 9 by 5 plus 32 comma Celsius. So let's break down this. See, first let's start with the lambda function. Lambda c is Celsius, which takes the argument. I'm naming that parameter name as c. And what is the expression? C star 9 by 5 plus 32. Okay. So how I am calling this lambda function now? So I am not assigning this lambda function into any variable like this lambda is equal to apply tax like that. I am not assigning this lambda into any variable. Instead, what I am doing is, since it is a list, I am using a inbuilt function called map. This map is not dictionary. This is map means it's a inbuilt function provided by the Python. Map, what it does, it takes one input here, and then my input here is function, anonymous function called lambda, and I'm passing a list or iterator through it. Okay. So here Celsius means this entire array, entire list. So what happens here in this particular line map means here we are doing this for each Celsius value, this lambda function is getting called. So first, what is the value? 0. So the 0 is passed here. 0 star 9 by 5 plus 32 means it's 32. And again, the Celsius value 10 is passed. Again, the entire value is the function is computed, this expression is computed. So this lambda function is called, or the lambda expression is called for each element in the Celsius or each element in the list. So finally, you will concatenate together with list. So you will get finally you are getting Celsius converted into Fahrenheit. Okay. So this entire three lines is we can written in one line like this. See, this is why, because okay, why, what is the point? You can just do like this. But yes, as you move ahead in Gen AI applications, there will be a lot of mathematical computations are there. So it's tough to maintain code if your expression goes too big. So that's why we'll use this anonymous function, simple and clean way, which looks code more readable and easy to maintain. Okay. So now if you try to print this, yes, Celsius means the input values, Fahrenheit after conversion. So let's run this first. See, the Celsius is 0, 10, 20, and this is the Fahrenheit converted list, Celsius to Fahrenheit. Now there is a one more example, numbers. Same here. So numbers equal to 1, 2, 3, 4, 5. So first apply the lambda function. So here the lambda takes only one parameter, and to that parameter this expression is for given. So it means x square of 2, and call this lambda function for each item in this numbers. Okay, and finally concat that into the list. Okay, so this entire one line is nothing but these three lines. Okay, see how powerful are the lambda functions. You can replace simple expressions. These are simple expressions. You can just replace that entire thing into one line here. So here I'm not storing the lambda into a function variable. With the help of map inbuilt function, here I am calling lambda with this expression, map of lambda function, comma numbers means for each item in this, the lambda function is automatically called. You don't need to store it in a function variable and unnecessarily make the complex logic. Okay. So yeah, this 1, 2, 3, 4, 5, 1, 4, 9, 16, 25. So now let's look into one more important example, lambda with filter. So here this is lambda with map and this is lambda with filter. So this is almost same. So you see you have a numbers and I want to define a logic to get even numbers from this list. Yes, you can write a logic like this for loop and then do all these things, but this entire thing can be replaced in one line with lambda. So for that I'm just doing filter. So filter means it only the values, only the expression which returns true are appended to the list, not all the values. So for example, if I take 1 modulus of it is not equal to 0. So okay, this expression returns false. So it is not appended to the list. Okay. So like that, for this entire list, you can for this entire list, for each item, this lambda function is called, and if and only if that it is even number, then only that gets appended to the list. Okay. So the entire normal raw, you can call it as pseudocode, or entire raw logic is converted into in one line like this. Instead of writing a function for even numbers and writing all the expressions, since it is a simple expression, you can define like this to get even numbers. Okay. So I'm repeating one more time. So this lambda function, this is the lambda function. This is called for each element in this list. And if the return type is true only, then only that value is appended to the list. So that is automatically taken care by this filter function. The filter is Python defined built-in function. So this will help us to ensure only the expression is returns true only, then only that will append it to the list. If not, no. Okay. So again, same thing. So here I have a list which has a names. So I want a logic which just filters only the strings which starts with capital A. So yeah, you can write normal logic, or how can you achieve that using lambda function? So this is again same. So this is my lambda function. This is the parameter of the lambda function, and this is the expression of my lambda, and this is my filtering. Okay, so what I'm doing is, if name starts with A, then that expression should return true, and then this particular whatever what this name got appends to the list. Okay, so for each item in the element in the list, so we're doing this lambda function, and if this expression is returned true, that particular value, whatever name is appended to the list. Okay, so same thing here. So now if we just run this, see all the numbers and the even numbers is this, and the name starting with A is Alice, Aisha, and Alex. And out of all these numbers, what are the positive values? 5, 8, 12. So a very to function can simply put forward in with a function which has very simple expressions. Instead of maintaining it in a multiple lines, you can put anonymously into a one line and then just make it the logic very simple and more readable and more maintainable. So that is the powerness of Lambda. Okay, so yeah. So now let's look into one more. Again, I am not storing this Lambda function into any function variable. So with this help of filter function, this is for each item in this list, this is automatically getting called. And the return value, yes, it is appended to the list. Return value here it is means that X, whatever expression is there, based on that it is returning the value. Okay. So now let's look into one more example called with sorted. Yep, this is bit interesting. See here I have a word Python and I want to sort this based upon the length, not with the alphabet. So my final output should be AI alphabet because it has two, length is 2, here length is 6, here length is 7, and here length is 9. So AI Python machine learning is the, I want to sort it in this way. So how can I do it in one line using sorted as well as lambda expressions and the key value. So this is how you do it. So sorted is inbuilt Python function, and here you are passing this list, complete list, and for each item in this list I am telling determine the length of the particular word. So yeah, sorted is a built-in function, and on what criteria I need to sort, whether I need to sort in increasing order, whether I need to sort in decreasing order, whether I need to sort in terms of length of the string, or whether I need to sort in terms of uh, alphabetical order with uppercase or lowercase. So that condition on what basis I need to sort, that condition you need to mention here like this, and that becomes very simple if you are using a lambda function. So what I am telling here is the condition is nothing but the length of the word, length of the string. So here first what happens here is first you will get Python and it computes the length, and then okay, and it keeps in one order, and then it AI comes, it keeps the length, okay, now this length is 2. So this sorted function will automatically rearrange accordingly inside. Okay, so the entire logic on sorting this by length of the string, instead of writing for loop and iterating each element and then finding the length and then arranging it, so everything is automatically taken care by this one word. So with this lambda function, when you're using with map, when you're using with filter, when you're using it sorted functions, it really helps a lot actually, because it is putting turning down a complex code or a very reasonably big logic into simple one line actually. Okay, so now let's, so same thing happens here. So I have a dictionary or a list which has set of keys and value pair. So the name and age. So the problem is I need to sort it by the age number. So how do you do it in one line using sorted and lambda function? Yes, this is the logic. So sorted of first I'm passing the students, which is the list of dictionaries, and then how to sort it, I'm telling key is equal to s of age, lambda of s of age. Age means this, each dictionary's age. So now first what happens here, this allies and age comes, okay, age is 25, okay, first it will keep in this order, and then once Bob comes, okay, 22, okay, now I will rearrange. So internally all that logic happens internally. See, remember, if you want to write a logic for this will be very not that straightforward, and it at least it will take 5 to 10 lines. But by using lambda functions or anonymous functions and with the help of this sorted function, so this is very easy. So sorted off and key. Key here is nothing but the expression. You can see here sorted means at a list or dictionary or anything, key is equal to function. So the function here is nothing but our lambda function, on what basis I need to sort. Whether I need to whether I need to sort on basis of length of string or the numbers or the age, increasing, decreasing order. So all those things we are keeping it here. Okay. So now let's compute this. Yeah, you can see sorted by length, AI, Python, machine learning, and sorted by age 22, 25, 20. By default, age means it is in increasing order only. Okay, you can also change this logic to make it into decreasing order. You can add one more key here, comma, reverse is equal to true. Okay. So what it will do is it will sort by age, bigger age first, decreasing order. Okay. So if you just compute this, you can see here, yeah, in the reverse of age, decreasing order, 28, 25, 22. Okay. So you can explicitly do this. You can tell like this, okay, I have a numbers like this. I want to reverse it. Okay. So it's simply reverse equal to true for each element. Key is equal to lambda x colon x. Here the expression is very simple, x colon x, because you are not doing any computation, you just want to reverse it. Okay. You can also here in this case, since your the expression is not required, you can also remove this and just simply apply reverse equal to true. But just to ensure, since we are discussing about lambdas, this is the more appropriate to define. Okay. So here you will get the descending order. So that's how you. So if the more more the data, the more the lambda functions will come into picture. Okay, the more easy it is used to compute or manipulate or do filtering, all those operations in the Gen AI applications or ML or NLP applications. Okay, so here is one simple real-time example you will see in AI applications. So here I have a data. Okay, so I want to apply some different filters to it. So if you want to go ahead and write for each function, definition, return types, all those things, simply you can write do like this in simple lines. So here first what I will do first, here I'm filtering out negative numbers. I want only positive numbers. So I'm simply doing this. So this is my lambda function p greater than 0 and filter it and then finally compute all the results into a list. Okay. So this filter will, what will happen, only if the expression type is true only, then only it will take. If the expression type is false, not true, if the condition is not meeting, it will not add to the list. So same thing here. Map means here for each value in the valid prices, we are applying a discount. So whatever positive values are written, for each positive value, we are applying a discount here. And after discount, we are telling the final prices. This is how we are computing. Okay, so if I just go ahead and run this, yes, so these are my original values, this is my filtered values, and this is my discount values, and this is my final values. Okay, so you can see how things are simple when you're using lambda functions from the code perspective. But here the main thing is understanding the syntax. So here I'm not assigning this lambda function to any function variable. By default, I'm calling this lambda function using this filter function. And after calling this filter function will only, if the expression returns only true, then only it will add that particular value into the list, not the expression, but the value which helped in determining the expression. Okay, so like that, using some built-in functions like filter, map, and then using lambda, and then normal way of declaring lambda, all these things are pretty much helpful in doing data pipelining in our ML and NLP applications. Yeah, so that's what that those are the key takeaways. Before ending the video, just see one more thing here. So so this is what we can do here. See, this is a regular function. Okay, use regular function instead if the condition is very not good. So in other words, what I can tell is, yeah, see here, bad lambda means, yeah, here there are multiple expressions here. Temp is equal to x star 2 and temp plus 1. So the multiple expressions are there here. So in this case, don't use lambda. If you have multiple expressions like this, just simply go ahead and use regular function and then do it. But here this is like fine. You have a score, if pass, if score, like that. If you can, anything that can be converted into a single expression, use lambda. But if you can't do this using a single expression, yes, mandatory you have to do it by writing step by step evaluation, then go for the regular functions. Okay, so let's run this. Yep, 11, pass, fail. Okay, so because here I'm calling the process value of 10, 5 into 2, 10, 10 plus 1, 11. And yes, if the grade 75, it is pass. If the marks are 45, what is the grade? It is fail. So I'm calling this function grade. Here I am storing this entire function into a function variable called grade, and I'm calling that function reference using this and passing the argument accordingly. Okay. So this is all about lambda functions, lambda using map, filters, and then dictionaries, and then yeah, and then syntax of lambda. So keep practicing more on lambda. You will be getting very familiar with it. And then just ensure if the expressions are simple, use lambda. If expressions are not simple and need more mathematical expressions, go ahead with the regular functions. Okay, so keep practicing. Hi everyone, Welcome to the lesson Python functions. Today we will discuss about decorators which are used for customizing the functions. So let's start with the basic understanding of what is a decorator. So it is in layman terms, it is a function that modifies or enhances another function without changing the code. So if there is a function and if you want to modify it or enhance it, you can do it with the help of a decorator without actually disturbing the actual function. So the analogy for it is wrapping a gift. So there is a gift, you should not disturb the gift, but still you need to enhance it by wrapping up it a gift cover. In the same way, you have a pizza, you don't want to disturb the actual pizza, but you want to add additional feature, you just add toppings to it. So it enhances the entire pizza. Something like that, a function, a decorator is a function that modifies or enhances the another function or the base function without changing the base function code. Okay, so now let's look at few examples. Before we go to the examples, let's understand few more concepts of function. So let's say this is a very simple function. Yes, definition, greet, and then the parameter of the function. It returns, of course, a string hello, and the parameter, whatever the value of that parameter. Yes, print greet alias. So here we are calling the function and we are returning the function here. Simple function that greets. So to this function, how can you add decorator to it? Okay, so before adding decorator, we will understand function as a what is function as a first class object. So this forms the basic foundation to understand about the decorator. So what is meant by functions as first class objects? So let's again come back to the basic definition of function. Say hello, it returns a string hello. And now as we see in the lambda functions, a function can be assigned to a variable. Now this is called as function to reference, and then you can call this function using this reference variable. Okay, so similar to that, we have a function instead of lambda function. Here we have directly a regular function, say hello, that also we can assign to a variable. Now this is a function reference, and you can call this say hello using this function reference. So that's what I am doing here. I am calling using greet function variable. I am calling this function say hello and it is printing hello. So this is called as passing or assigning functions to the variables. So there is one. So this is one way of using function as first class object. So the another way of using function as a first class object is passing it as a argument. See here you have a function, and then yes, so the argument, the parameter of this function is a func, which means it is expecting not data types. It is expecting function as an argument. Okay, you can pass the function here. So for example, execute underscore function. So says hello. So here I am passing function as an argument such that this particular execute function will read that particular function and execute it. Here read means this is again a function reference function also. Okay, so result is equal to function of, and expected is the result, which is hello. Okay, so let me repeat again. We are discussing about decorators. So to understand the decorators, we need to understand the concept of functions as first class objects. In the first layer, we are saying how to pass or how to assign function to variables. Okay, so here say hello is a function and we are assigning it a variable, and we are calling the function with the help of this reference variable. Same thing, extending this topic, instead of passing parameter, I mean, we can also pass function as a parameter. So here I have execute function. So I am passing here a say hello. Say hello is nothing but a function. So now what happens inside this function? Result is equal to function of. So this is nothing but you are indirectly executing say hello, and it returns hello, and then the expected is hello. Okay, and now this is one more extending this topic. It is like functions can return other functions. This forms the base for understanding the decorators. See, carefully observe here. So first let's run these two things. Yes, so we know that is selling as expected. This is hello, and this is executed hello, which is fine. Now let's see this third example. So functions can return another function. What is meant by that? So you have a function create multiplier. Here you are passing parameter n to that function. So what is this function doing? What is the functionality of this function? Inside this function, we have a one more function which is just returning the object reference for that function, right? In other words, yes, here is the function definition, define multiply, and this function is returning one more function called multiply. Okay, a function returning another function. Remember this. Okay, so now how to call this create multiplier and how to call this multiply? Let's see. So what is the function that is exposed to us as a user? Create multiplier. So we don't know what is inside this function. Okay, so now let's say we call create multiplier. So I'm calling this function create multiplier and I'm passing this argument 3. So what it returns? So it returns a one more function called multiply where n is equal to 3. Okay, so times 3, that's why I mentioned. Now since this is a reference to this multiply function and times of 3 of 10 is 3 into 10 30. Okay, so this is called calling a function within the function. Let me repeat. So this is a function. This function returns another function called multiply. So when you're calling the function, first you call this base function, or I mean the actual function create multiplier, and you're passing the argument as 3. Since this function returns a one more function, you can store this function reference into a variable called times underscore 3. So here times underscore 3 is a function referring to multiply. Okay, it's not referring to create multiply, it is referring to multiply because this function is returning another function. In the first case, this is returning straight away returning the same function, so we can call directly. Okay, here a function is returning another function, so the reference type we are here as multiply. So now here times 3 of 3 means indirectly I'm calling multiply of 3. Here already n is 3, x is 10, 10 into 3 is 30. That is the output. Okay, so now this is called a lame decorator in layman terms. So now let's reciprocate the same concept for decorator. So let's say you have a function make bold. That function is returning one more function called wrapper, and the functionality of the wrapper is yes, it is calling the actual function, and to that actual function without disturbing it, you are just adding uh, kind of this asterisk symbols on top for the result in the pre-index and post-index. Okay, so this is a function. That function is nothing but it executes the actual function and adds some decorations in before and after. Okay, so now this is the actual function say hello return hello world. Okay, this is nothing but a function within a function, and then this is similar to this create multiplier multiplier. How do you call? Okay, execute function. So now say hello is a function, use the decorator manually. Okay, so this is as I said, so make underscore bold is say hello. So here I am call, so first say hello is passed to this make bold. So this executes this function, and then it adds the function is nothing but say hello. It comes and execute hello world, and for this hello world here and here you're adding asterisk symbols. So now let's execute this. Yes, it is calling hello world. So basically you are decorating this function say hello with these asterisk symbols. So what is the syntax we follow? So we need to pass this say hello to the decorator. Okay, so the decorator is nothing but make bold. So what this decorator does, it executes the function as it is, and then it appends the results to it. Okay, so this return wrapper will return this entire function. Okay, so how do you call the decorator? So first you need to the decorator make bold. You need to send the actual function. So this is like my pizza, and this is my adding toppings. Okay, so I am passing the actual function to the decorator called make bold. So that is assigning this entire thing is returning a function called wrapper, and that we are assigning to a function variable called bold hello. So now straight away we are calling this bold hello, and finally we will get the output wrapped up with the decorators. Okay, so now this is about the creating a simple decorator, but as you can see this is not that straightforward. It is always confusing. So the more simpler way, the more easiest syntax to a decorator is at the rate make bold. Okay, so here you have the decorator and you have the actual function, and to this actual function you are attaching the make bold. Okay, at the rate make bold It means, okay, for this say hello, there is also a decorator. It means this entire function is passed to this as an argument to this make bold function. Okay, no, but in this case, the if you by defining like this, you can the way you are calling the function becomes much more easy. You can directly call this say hello. Okay, so now I just call simply say hello. So what it does, it first it calls make bold since there is a decorator, and for this make bold function, this function is passed as an argument. So now make bold is called, and this function entire say hello is passed as an argument. And first, okay, it is telling return wrapper. So now it goes to the definition of the wrapper. The wrapper executes the function. Now here we get hello world. So that hello world is decorated here like this, and finally we are returning it. Okay, so this is what happens. Very simple way of calling a decorator. So this is more of a complex. First you need to call decorator, and then to the decorator you need to pass the actual function, and then assign to a variable, and then again call that use that function reference. It's like more of, so you can simply call in one line. Okay, print say hello like a regular function you can call, but this since we are attaching to this regular function at the rate decorator, it means it will this entire function is passed as an argument to this function make bold, and then finally you'll get the decoration. So this is how a decorator works with the help of at the rate symbol, like or attaching that decorator to the base function. Okay, similar example. So here I have a say goodbye. Now I can reuse this decorator. It's not like this is limited to this one particular function say hello. So now I have a decorator defined. So now I can read at the rate make bold. So what it will do? So now what happens if you say goodbye? So to this goodbye it will decorate. So this entire function is passed as an argument to make bold, and this make bold function get executed, and finally that resulted string will have these asterisk symbols decorated before and after the string. Okay, so now let's see one last topic in decorators, that is decorators with arguments. So here the decorator doesn't have any arguments here actually. Whatever function you are calling, this doesn't have any arguments. So now let's say what if the decorator has arguments in the sense, so this wrapper whatever decorator, it takes two types of variables. This we have already seen in the last class. So this is about positional arguments, and this is called key value arguments. Both takes list as an input. This takes list as an input, and this takes dictionary as an input. And these arguments you are passing to this actual function, and then finally you are converting the result from lowercase to uppercase. Okay, it means it is expecting some string variables. That's what we can tell. Okay, so now this is my original function greet, and I have one parameter passed to is called name, and I have a decorator attached to it. And now this decorator has some arguments with it. Decorator with arguments. It means a function inside a function, that inside a function has now some arguments. Okay, so print greet of ls. Let's see what happens here. So first greet is called. So as soon as the Python interpreter sees greet, okay, there is a make uppercase a decorator attached. So now this entire function is passed as a reference to this make uppercase. So now result is equal to function of. So what are the arguments passed here? The arguments passed here is lis. So it executes the function with that lis, which is nothing. So that it means it executes this particular function greet. So now it comes hello lis. Okay. So now the entire string we are converting from lower string to upper string. It means from lowercase to uppercase letters. So finally we get hello lis here. Okay, so it's simple in one line. So here in earlier example we are not passing any arguments to the decorator. Here we are passing arguments to the decorator. Passing arguments to the decorator means we are passing argument to the actual function, and this entire function, since it is passed as a reference to this decorator function, we are telling we are passing arguments to the decorator function. In that case, these arguments are carry forwarded to the actual function and then executes, and then the entire thing is wrapped up. Okay, So this is how. So now if you pass this, now same thing here. Full greeting. So welcome. Here I am passing two arguments here. Bob and Smith. So what happens? So it first calls full greeting and it notices okay there is a decorator attached to it. So now let's pass this entire function along with the arguments Bob comma Smith to this. So now the result is equal to function. So which is Bob Smith, and then it converts both things to it executes the function. Now it says hello, the name is Bob Smith, and now it converts that entire thing into uppercase. Okay. So let's execute this. Yes. So it says hello allies and welcome Bob Smith. So that is how you use decorators without arguments and decorators with arguments. And to understand what is decorators, you need to understand function as you need to understand function as a first class objects. So you need to understand is how the function returns another function and how do you call that function from the outside. So all these examples you can refer to then practice assignments. So that's all about the decorators. Hi everyone, welcome to another lesson on Python functions. Today we'll discuss about function documentation, also called as docstrings. So why these docstrings are important? See, when you're writing any algorithm or any logic, so we'll be using lot of functions. So every time it as the code grows, as we keep working on, we do not remember sometimes what that function does and what are the inputs, what are the outputs, what are the exceptions that function raises. So it is better or maintain any document for that function. But at the same time, you can't write a separate document. So to solve this problem, there is a concept called docstring. So here what happens is, let's say if you have two numbers, add a comma b. So it's simply, if you call this function, it will return 5. But let's example, there's a very big function and as you keep on working on different modules and different code, you generally tend to forget what that particular function does. So here what we do, you can introduce a docstring called what does this function does. It simply says adds two numbers and returns the results. So now if I run this, is yes, this is just calling the function, and the second file is calling this function. And if you print this add underscore doc dot underscore underscore doc, you will see okay, add this two number, return the results. So let's say this function is inside another Python file, or if this is coming as a library. And if you want to see what this function does, you can simply call this and then see okay, this means it is adding two numbers and returns the result. So that's how you can just maintain, or else if you want to modify this function, you can just simply look at this comments and then see okay what it does. Okay, just like a recollecting what is happening. And now accessing doc strings. As I mentioned, this underscore doc function dot underscore underscore doc underscore underscore. So this is how you access a doc string. Here the function name is add underscore doc. So that's why I'm calling add underscore doc the function name with the method dot underscore underscore doc underscore underscore. Okay, this is how you access a doc string with the help of the function name. Okay, so there's a one more way you can access a document string using help function. So this is a Python built-in function help. So you can just use this help function and then just call. So all you need to do is you need to, for help, you need to pass this function. So it will automatically print the document for you. So now let's see both the cases. Okay, so here I say multiply two numbers and then my doc string is multiply two numbers. If you access the doc string, you will get this multiply two numbers. And what happens if you call help multiply using this help multiply? This also provides a doc string, but in a different format. Help on function utility module, multiply a comma b, multiply. It gives more explicit details. Okay. So this is about doc string and how do you access doc string. So now let's see uh, different styles of documenting the function. So let's start with a good doc string. So here this is called, a function is called calculate area and it has a parameter radius and it returns pi star radius dot 2, which is a floating number. Okay. So we are capturing everything this here, which this function calculates the area of the circle and the arguments it takes is radius, which is a float, which is called as radius of the circle, and it returns a float, which is the area of the circle. So we are clearly mentioning what this particular function does. Not only this function does, what are the input variables, it data types, and what is the return type, and what is the data type. So everything we are clearly mentioning here in a step by step constructive way. Function, definition, arguments, and return type. So this style of documenting is called Google documenting also, Google docstring also. So we'll just run this first. Yes, you can see the first is you are calling the function, it just computes and prints the value. Second, I'm accessing the docstring using calculate the function name dot doc. So it is printing whatever docstring it has. Okay, so this is much more readable. So this particular style is called Google style. Okay, so now let's look at one more style called NumPy style. So here same thing, the Google string, Google formatting of the doc string, and these are both same. Here just instead of colon, we are using underline. Okay, parameters. Yes, the parameters are values, which is of list of float, and that list should contain numerical data types. And return is yes the average value, which is a floating point. So the now if you just compute this, yes you can see. Okay, this is the docstring generated. Compute the arithmetic mean of a list of numbers. This entire docstring is returned now. Okay, if you are accessing the docstring. So now there is one more way of formatting the documentation for a function, which is called as restructured text, or you can call rest docstring. So here you can pass multiple things. You can define the function, and then you can define each parameter. Okay, parameter A is called numerator, parameter B is called denominator, and its type, what is type, and what is the return type. So you can explicitly mention each and everything in this restructured format. So you can also mention, yes, it returns an exception called value error, and exception type is value error if B is 0. So not only we are mentioning function definition, parameter names, return types, we are also mentioning about the errors it might occur. Okay, these we are adding some additional details in the restructured format string. So now let's run this. What kind of doc string it returns? Yes, it returns this divide two numbers param. So whatever we defined in the quotes, multi quotes. So as you can see, the entire doc string is defined in the multi quotes, whatever the version it is there. Okay, so next is about documenting exceptions. Yes, you can see here we already added here documenting the exceptions. Same thing we are seeing here. Yeah, here I'm using the documenting the exceptions not only in restructured format is not there. There are also other in other Google format and also in NumPy format also you can document the exceptions. This is what I'm showing in that example. So this is the function name, these are the arguments, this is the return type, and this is the exception I'm telling. The keyword is raises, returns args. Okay, so that's how only the syntax varies for the docstring, but yes, from any style you can return all the things. You can define anything. You can define function definition, input parameters, output parameters, exception types, everything you can. Okay. So now let's run this. Yeah, the element is B, but of course, if you access the docstring, you'll finally return this. Okay. Yeah, so why does docstring matter? See, if you are using any public, say, in general, we will be using a lot of public APIs. APIs means application programming and interface. So you need to before, so the code is hidden in that APIs. You do the how we understand about that API is we will just call this docstring function. Okay, then you'll come to know what is that API, how it is used. And if you want to share the code, let's say across multiple developers, they doesn't know actually what is this function does. So they will access docstrings and see okay what it does. So of course in data science and ML, there are a lot of algorithms, functions which you are not sure to just to recollect what it does. We can access this docstrings. Okay, and also there is also a tool called Spinx and mkdocs which actually create, you can see in GitHub or any other, there are readme files. So based upon all, so let's say once let's say there is an Android version, new Android version releasing. So how the documentation is done for that new Android release version? So they will maintain something similar called docstrings, and they will use these software tools called Spinx or mkdocs, and with them they'll generate the entire docstring for that particular software. So not only from the usage perspective, from the deployment perspective also, this docstring is important. Deployment means releasing a software. So this is all about docstrings and how it is useful in real cases. See you in another video. Take care. Bye.